If I give you some numbers like this and say that this sequence of numbers goes till there are 30 terms, can you find what the 19th and the 23rd terms in this will be? There's one surefire way to do it. Just extend the sequence all the way till 30 terms. And how will you extend the sequence? You will notice a pattern. The pattern here is, the jump size is 3, 3, 3. So you will trust that that's what this person is telling you, that keep jumping size 3. Don't change the jump size and keep going. Go till 30 terms. Then you can go see which was the 19th term, which was the 23rd term. That method will surely work. In this case, because it's 30 terms, it will only take you a few minutes. But if this were, 3,000 terms and you want to find the 1900th term, that's going to be much harder, at least much more boring. So we have to figure out a clever way to do this. And the first thing we saw was the jump size is a constant. Now, whenever that happens, the sequence is called an arithmetic sequence, and these numbers are said to be in arithmetic progression. But that's not essential now. We just know that the jump size is constant. And like we said, only knowing that, let's derive everything else that we want. So I have 4 as my first term. 4 as my first term. Let me see what 7 really is. 7 is 4 plus my jump, right? 7 is just equal to 4 plus the jump that I made, which was 3. I had to jump 3 from 4. What about 10? 10 was my 7 plus 3, or in other words 4 plus 2 jumps. 4 plus 3 plus 3. Now what about 13? You see the pattern here. It's 4 plus 3 jumps. So 4 plus 1 jump plus 1 more jump will give me 13. So I have 4 plus the same jump 3 times, plus 3 plus 3 plus 3. Now I'm using the fact that my jump size is constant, right? That's the only thing that makes my pattern meaningful here. This jump size doesn't change. It's always 3. And then I see, okay, is there a pattern here? My first term is 4. No jump here, or 0 jumps. My second term has 1 jump of 3. My third term has 2 jumps of 3. My fourth term has 3 jumps of 3. Then I go, okay, what I already saw the pattern, so what term do you want? You can give me any term and now we can find the answer, right? 19th term, sure. That's going to be 4 plus, what is it going to be? For 3 it was 2, for 4 it was 3, so I need 18 jumps. 18 jumps of 3. Pause for a moment and convince yourself, right? I had to write 4 plus 3 plus 3 plus 3 plus 3 18 times. I just wrote that as 18 into 3 because there's no space to do that. And notice that for the 19th term, this will be what I want. And this is going to be equal to 18 threes will be 9 6R. So 54 plus 4, that's 58. 58 is my 19th term. What else do you want? 23rd term. 23rd term. 23rd term is going to be 4 plus 3 added 22 times. 3 added 22 times. So 22 jumps will lead me to the 23rd term because 1 jump led me to the second term, 2 jumps to the third term, and so on. So 22 jumps to the 23rd term, and what's that going to be equal to? 66 plus 4, which is 70, that's it. 66 plus 4. So 23rd term is 70. Now, why stop here? Any number that's given here, if you had to give the nth term, what would you say it is? I can put an equal to sign here. These can also be equal to's. The nth term would be the first term. And notice that this is specific to our sequence here, but anything, this 4 is basically the first term, right? So if I call the first term in general as a, or a of 1, basically the first term, plus something to do with the jump size. How many times, the size you jump, right? Let me call that d. What's called the common difference. Like this big serious way for the jump size is the common difference. This is basically what's the size you jump whenever you jump. And this is a constant, right? It's the common difference. And then over here, what is this? If you want the nth term, if it's 23, then here you see 22. If you see 19 here, here you see 18. If you see third term here, you see 2 jumps here. Fourth term, you see 3 jumps here. So it'll always be 1 less than this, right? And that makes sense if you think about it, right? Because at the 0th point, at the first term, you have jumped 0 times, right? So second term once, third term twice. So it makes total sense that you have to jump n minus 1 times to reach your nth term, starting from the first term. This is also called the expression or term or formula or result or whatever for the nth term of an arithmetic progression or an arithmetic sequence. But notice that you needed nothing other than learning that the jump size is constant to get here.